It is nighttime for me. So, however, good morning, everyone. It is an honor to be here today, OSSFE 2025. My name is Ahnaf Chowdhury, and I am the founder of NukeHub, an open source platform dedicated to advancing nuclear technology by making tools more accessible, integrated, and collaborative. Today, I will walk you through the challenges facing the nuclear open source ecosystem and now how NukeHub is addressing the issues. Let's start with the problem. So, the open source nuclear software landscape is highly fragmented. While some tools work together, many still operate in silos, making it difficult to create a seamless workflow. Setting up these tools is often complicated, requiring complex installation that discourage potential users. Researchers, students, and industry professionals end up spending more time on troubleshooting compatibility issues than actually innovation. This shows the progress and make it harder for nuclear leadership technology to advance the speed up we need. Let's see an example for a moment. For example, let's start with OpenMC. As you can see, you can simply install OpenMC if you are familiar with Conda, but there is a catch. It doesn't come up with all the plugins you need for your specific purpose. If you are going, for example, you need CAD geometry, you need something here that is not available. So you need to go with compiling those tools, and you will find that you need something like, for example, right now OpenMC comes with DugMC, and DugMC uses Moab. Now you might be saying that, yes, I do have Moab, let's do my deal work. But you are a higher-end fusion technology company, and you are working with high mesh projects. And now you found that the Moab is so old that it can't work with GPU. Now you need to come up with another technology that is going to solve your issue. So what you are doing, you are just troubleshooting your things and without your innovation. So that's why let's make it a little bit easy. For example, in your quick installation guide, here we have examples, and in the example, let's see, here is a button that is saying that try it now. And after clicking on it, you are in a dashboard where everything is available. OpenMC is installed with all of its built-in environment ready. The environment that you want to use, there are multiple environments for your workflow according to your workflow, and you can use it. And after running it, everything works fine. So how easy is that? Okay, we have discussed about the problem. Let's go to the solution. Okay, what's the solution? The solution is we need a central platform that brings nuclear open source tools together and make them easier to use. By simplifying access, we remove technical barriers, help researchers, students, and industry experts collaborate more effectively. Our goal is simple. Speed up innovation. Instead of wasting time fixing software issues, people can focus on real research and development. Imagine a researcher who needs to simulate neutron transport while considering material interaction. Right now, they might spend up weeks setting up different tools. With NukeHub, they can do it in one place with minimal setup. Actually, there is no need any setup. That means faster results, better research, and more progress for the entire nuclear industry. And that is why this is our NukeHub, empowering nuclear innovation. Now you might ask, why NukeHub? Because we are solving big problems in education, accessibility, and technology. Right now, nuclear research is held back by scattered tools and complicated setup. As I have shown you, we are going to change that. Our platform directly supports the United Nations Sustainable Development Goals. First of all, we are going to support SDG 4 for quality education, then affordable and clean energy, which is SDG 7, and SDG 9 for industry, innovation, and infrastructure. By Bringing all these nuclear tools into one place, we are free researchers, students, developers to focus on real world challenges instead of spending time on setup and debugging. With NukeHub, we make nuclear technology easier to use, more accessible, ready, and drive innovation. Now, here you can see when you are just using the open source tools, you need to give a huge effort on everything. For example, you need to do manual setup, you need to do debugging. I have already shown you those in the previous slides. And with that NukeHub, you can see that you don't need most of them to do because you can directly jump to the technical expertise, regulatory explainers, and accelerated development. And these are some things, this is recommended. However, much more technical expertise you do have, much more innovation you can do. So, but however, you can reduce these type of tools here. Okay, let's go to the market opportunity. So, who benefits from NukeHub? First, fission and fusion startup. These companies are racing to bring next generation reactors online, but they need better software tools to streamline development, simulation, and regulation. NukeHub gives them that edge. Then comes the National Lab and Research Institute, the same thing. For the university, the next generation of nuclear engineers need hands-on expertise with real-world tools. By making nuclear software more accessible, NukeHub helps bridge the gap between academia and industry. Finally, the government and policy stakeholders, as nuclear energy expands, policymakers and regulators need better data-driven decision-making, so NukeHub can help on that as well. Okay, let's talk about a little bit about market size. Open source software in nuclear fusion is growing rapidly. More companies, researchers, and institutions are recognizing the value. At the same time, the demands for streamlined integration is also increasing. So that is why we say, NukeHub, you are ready for action. Okay, so let's discuss about our current process and milestones to fix the issue. So first of all, if you go to our NukeHub website, you will see there are a bunch of projects out there, but this conference is specific to nuclear fusion, so that is why I am just focusing on NukeLab today. But if you are interested in other tools, you can go and check out, but these are for fission reaction only. Okay, so first of all, let's discuss about the NukeLab. So first, as you can see, NukeLab is cloud-based. You don't need to use a high-power computer to run the NukeLab. It is fully open source. It comes with integrated Nuke IDE, which is TIA-based, not VS Code-based. That means you have all the VS Code functionality. Those people who are familiar with it, you already know. Pre-configured environment, as I have shown you, you can see there is a pre-configured environment for Python, and here you can get the CAD geometry or everything. You can do all the neutronic simulation with that. We are also adding more environments for future, but right now we do have this. Okay, for security purpose, we are using containers. So every person has his dedicated container. We will discuss it a little bit later. We do have built-in storage support, so you don't need to waste your safe data. It will be stored in our system if you want to. And the good thing is there are 60 people who are already adopting it and checking out if things are working or not. So good bug fixing. So let's talk about how the NukeLab is actually working. Let's suppose you are the client. First of all, you will come to the NukeHub website and try to log in, and you will find out that there is a Jupyter Hub is running in the backend, and it will just give you the GitHub authentication. And once it is checked, you will enter to the Jupyter server. The Jupyter server will save your some personal information about your username, thus you can access your data later. It is necessary, however. And after that, it will spawn a completely new container for you with a dedicated server. That means you will go enter a new computer with everything is especially for you. But there is a catch. When the container gets down, every data will be lost. But there is a folder available called work directory, where you can place your data and it will be saved in the server. However, if you use the Jupyter server, it will come up with conda base. The conda base we are using, which will store all the C++ and Node.js technology. You can run all of them from there if you want to write C++ code. And if you are looking for Python code, you can use the Nuke environment. And Nuke IDE is that which can be used for that. Okay. There are some roadblocks. First of all, single server limitation. We are not yet scalable to Kubernetes. Kubernetes is more better than the Dockers. However, because we have only one server available for NukeLab. Second, despite our vision for a collaborative ecosystem, NukeHub is currently open person effort. I am the only developer currently working on NukeLab specific projects. While I have receiving mentorship from leading experts like Paul Wilson from Wisconsin-Madison, John Shimwell from Proxima Fusion, and Patrick Wise, who is from ANL. And thank you so much, you people, for supporting me for making this happen. Lastly, funding is also crucial bottleneck. While I have received partial funding from Proxima Fusion, thank you very much for contributing to projects like OpenMC and VMCC++, Proxima Fusion funded me. I must say thanks. Sustaining and expanding NukeHub requires further investment and to attract more contributors for development. These challenges are precisely why we need strategic partnership and financial support to make NukeHub to the next level. And that brings us the next question: what impact have we made and how we can scale that further? Okay, let's discuss about the business. Oh, I have skipped the roadmap. Oh, yes. So the roadmap is here, what we are actually going for. In 2023, we have created the NukeLab with the NRMS, which are fission things. And in 2024, we create the NukeLab, which is come up with a Jupyter Lab at that time with OpenMC workflow only. After 2025, we have launched the Nuke IDE. And if you go there, you can see that we have already get so many likes and comments for that. However, if you go to that, our planning for 2027 is integrating different plugins to Nuke IDE. Thus, it will give us a workflow. For example, if you are trying to work with OpenFOAM, we will create the plugins for you for that, and you will get the GUI. But you need to create an issue for that, and we are happy to do it. Since we have seen the issue, some of you have mentioned that you need some GUI-based workflow for OpenFOAM. We are happy to work with it. Please let us know. We are also planning for advancing feature like AI-powered insight, and also after the 2030, we are planning to make it industry level, thus we can fight with the modern industry solution like ANSYS. Not kidding. So our business model. First of all, you might be wondering how we sustain this. NukeHub operates as a nonprofit focusing on education and research. However, we are seeking grants, strategic partnership, and sponsored projects to support the development. Additionally, we plan to introduce premium features for advanced users. For example, if you do have a company and you need to get extreme server, we are going to give you experts that you can run your server, and we are going to deal with that. You don't need to deal. Your researcher is going to work on the innovation, and we are going to deal everything by ourselves. So it is an enterprise system as the Red Hat do. Now, you might be asking that why invest in a NukeHub? First, impact. This is about the future of clean energy. Nuclear power is growing fast, and NukeHub is building the tools to support the growth. Second, scalability. With the right support, NukeHub can become the main hub for nuclear open source collaboration. With this help, researchers, startups, and companies work faster and smarter. Third, global reach. Nuclear technology is needed everywhere. NukeHub can make important tools for accessible to people around the world, helping the entire industry move forward. I think you already know about the Galaxy for bioinformatics, and you might know that it is that much easy for the people who are not in bioinformatics. If you go to their website, you can see there are a bunch of tools over there to guide you, and you can easily use it. I'm sorry I haven't included that in my slide, just remember that right now. So finally, I would like to wrap up things. NukeHub is a mission to unite the open source nuclear landscape. We are making high quality tools accessible, scalable, and impactful for the entire industry. We have identified the challenges, built the foundation, and now with the right support, we can accelerate the transformation. So here is my ask. With deep respect for everyone in this room, however, you are an investor, a researcher, a professor, or a student, your support can help shape the future of the nuclear industry. Trust me. Investors, if you believe in the power of open innovation, let's work together and take NukeHub to the next level. Professors and researchers, your insights and expertise are invaluable. Let's collaborate to build the tool that nuclear science truly needs. Students, you are the future for the field, and I am also. Join us, collaborate, and be the thing that will define the next era of nuclear technology. I'm love to continue the conversation. You can reach me out at Tahmid@nukehub.org, or you can visit the NukeHub, and together we can make a very beautiful thing for the society. Thank you very much. If you have any question, please feel free to ask.